Hi guys, in the last parts of the video we looked at homogeneous and heterogeneous catalysis. In all the examples we looked at, the catalyst was something we needed to add to the reaction. But there's another type of catalysis we study called autocatalysis, and this is where a product of the reaction in question catalyzes the reaction itself. So something being made within the reaction then speeds it up. So one of the best ways to see how this works is to go through the example of ethane dioate ions, which look like this, and are closely related to ethane dioic acid, but it's lost the H pluses. And these will react with potassium manganate 7, and the reaction is catalyzed by manganate 2 plus, which is produced as a product. So if we look at the equation, we have our ethane dioate ions reacting with our permanganate. Remember that permanganate is another name for manganate 7 ions. This all takes place in acidic conditions, and it produces manganate 2 plus ions, which then catalyze the reaction. Just like in the example where we looked at homogeneous catalysis and the persulfate ion reacted with iodide, on its own, this reaction is going to be slow because the negative charges on the two reactants are going to repel and they need to be near each other to react. It's much faster if we have something with a positive charge reacting because the opposite charge between that and each of the reactants will attract, and the manganate ion provides this positive charge. We can draw a graph to show how an uncatalyzed reaction progresses. So initially, there's no products, and this means that there's no catalyst, and therefore we have a slow rate and a flat graph. Because remember that the gradient of a concentration time graph gives us the rate. In the middle, we have generated Mn2+. This is the catalyst for the reaction, and so the gradient has got a lot steeper. We're at a steep bit of the graph, showing that the rate is faster. When we get to the end, however, we've used up most of the reactants, and so the rate is slow again. So now let's look a bit closer at the reaction between ethane dioate ions and potassium manganate 7 ions. We've seen the overall equation, and that one of the products, the manganese 2 plus ions, is then going to be acting as a catalyst for the rest of the reaction.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.